In the description below, you can find a link to the GitHub page with the full source code for lesson 1. So for this lesson, we'll create 3 surfaces. We'll create a game window surface, and this will be the only surface we'll display to our screen, so our monitor. And we'll create 2 different surfaces. One will be for our menu screen, and one will be for our game itself, so the game surface. So both of these surfaces will be displayed upon the first surface, which is the game window surface. So we'll take times switching between these 2 surfaces to display on the monitor. So when we start the game, we're going to display this surface first upon this surface. And then when we click play, so we go into our game menu, now we're going to remove this menu surface and display this game surface upon the monitor. So before we start with the lesson, let's quickly take a look at the game in its current state. There will be major improvements later on. And we can see from the menu, the game is supposed to be outlandish and ridiculous and kind of like a major joke, like a parody to the extreme.
California, baby. We will tax the rich and give to the rich so the poor can be rich. I think that is how it works.
My economic plan is simple. Make the numbers up.
Why are you slow? Is my girlfriend a spy? Who knows such things? Say hello to my little friend.
Mr. President, is it true your plan to build a wall?
If you do not love BB, we will cancel you.
Ice, baby. I quit sculpting like a pro. As far back as I can remember, I always wanted to be a gangster. I'm an undisputed gangster.
October 7th and K911.
What a retard. Activate the space laser.
Shalom, 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 shalom.
Show us the Epsilon files.
You're dead.
Shalom, 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 shalom.
Buy my book Sinner. Even hell has merch.
Shalom, 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 shalom.
Send it ice.
The roach has been summoned.
The Titan dodges bullets like we are in the Matrix.
The real victim of 9/11 was my family who got stinky looks.
No one can beat me.
Officer Zionist show reporting for duty.
I love clean energy, especially when it cleans out taxpayers' wallets.
I only see people that have over 1 million followers.
Shalom, 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 shalom.
Send it, little one. Maya.
Ignore what happened to CK. Candace is a liar unlike me. Hail sign overlords.
Who cares about New Yorkers? Give me all the money.
My kettlebell has seen more of my emotions than my therapist.
Shalom, 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 shalom.
Let us doge to that.
No king, but an emperor.
Still got the move.
tax the rich? Except my family and friends, of course.
Shalom.
Your
Shalom.
ass is fired.
Shalom. Shalom. Shalom.
I'm an undisputed gangster.
It's possible that I'm a little too off.
No king, but an emperor. The Titan God is glowing.
Joe Rogan won't let me on his podcast.
Drop the midnight.
Time to get my baby up again.
I got the hibby-jibbies.
C, stop whining.
By my, you don't think chimps eat babies? You haven't been paying attention to the literature.
I hear you. I'm not sure what you said, but I hear you.
I am a Titan.
Who cares about the Epstein files?
Imagine how strong gorillas would be if they knew bodybuilding.
Ice baby.
I want to go to Mars.
So within our lesson folder, lesson 1, create 3 files. So we'll create a main file for our main game loop. We'll create a config file for our configuration for our game. So settings, characteristics, and then we'll create a menu file to host our menu logic. So within our main game file, we'll import the Pygame. So this is a library with modules that we can use to build our game. So I'm just going to use type ignore because I have a small compatibility issue with my code editor. You can ignore the type ignore. So that comment is only for my editor. Now let's create a function. So when we start our game, we're going to use this function to clean some of the sprites to reset some of the properties of our game. So this will be our main game function. And when this function is triggered, we're mainly going to use it to reset and make sure our internal workings of our game is perfect. So we create that function. We'll call it start game. So when we start a new game, we call this function kind of like a helper, but our main game will be within this function as well. Now, whenever we have a game, we have events like keys, like pressing keys up and down, or maybe we have created a custom event like spawning enemies, which we will. You have to make sure that these events and the pool, like the backlog of events, are cleared. Like when you press the jump key, you've died, and when you start again, you jump automatically as soon as the game starts up because the event's still saved. And then we'll create a variable which will be like a flag, a boolean for playing. So our playing is going to be checking if it's true, the game plays. If it's false, we're not playing the main game. So the main game loop is false. The game is false. We're not playing. Game over. So we'll create our while loop. So while playing is true, we're in our game. Now let's go to our config file. We'll set it up with some basic settings. So we'll import the Pygame library as well. Again, I'm adding the comment for my editor. So with Pygame, it's important that we initialize Pygame, so the library itself, at least once within our game file. So I'm going to do it within the config file. So when we import the config file in our main, we're going to import it first before any other custom modules we're going to create. And this will allow us to initialize Pygame and its internal workings. This will allow us to take control of many sub-modules like font or display or time within Pygame and use this effectively within our game. Now let's set a title for our game, so a caption. So at the top left corner when we run our game, you'll be able to see the name of the game, the title. So when we run our game in Windows, you can see at the top left corner here, we have the full name of the game, the title. And when we run the game, it's the same, even within the main game menu. So I'm going to call the game the Triumphant Tower Defense. The name is quite obvious. Triumphant, we know for what it means for, and it's a tower defense game. It's a little bit unconventional in terms of a tower defense game, but it's a tower defense game nonetheless. Our towers are just politicians and famous people and parodies of them, rather than just being a normal traditional tower. So with the following code, we can basically save the info of our monitor we're running on. So when you run the game, you check for the user's internal display. You get the info, and we can use that info to get the width and the height of that display. And then we save that current width and height within a screen width and screen height constant variable. I'm going to comment it out because I do not want to run the game at the internal resolution, because someone might run a 4K or a 5K monitor, or possibly even an ultra wide. So we're going to force full HD. So we're going to force the monitor to go to a full HD native resolution. by just using 1920 by 1080. So within this game window variable that we're going to create, we're going to store our screen surface. So we'll call the Pygame library, so Pygame. We'll call a submodule within that library, display, so we'll call that module. And then we'll call a function within that module, so within that file. So now we're going to set our screen size. So we're going to pass our screen width and our screen height, which is 1920 by 1080 pixels. So 1920 width by 1080 height. And then we're going to tell Pygame, hey, listen, we want full screen. If you do not add this full screen, if you have a game screen here, you're going to have a small title bar, not as large as this, with the name, so your title, and that exit button, like we have with most programs, like this one here I'm using to demonstrate. So if we add this, we remove this title bar, and we only have our full screen, which is what we desire. Now, if we look at our next two variables we're going to create, so we take our frame rate. This is going to be a clock that we create, so we can see a clock. So from the Pygame library, from the submodule time, we have a class, so you can see it's a capital letter, so it's a class, clock. Now this clock is not like a normal clock. Normal clock just ticks, ticks, ticks. This one has a different function within Pygame. It keeps track of time between frames. So you can see here in FPS, so frames per second, our game is going to run at 60 frames a second, so 60 images. Any game is just a combination of images displayed one after the other. Movies are the same, but games are different than movies in terms of they require live computation. So we do computation upon the images directly and live, whereas movies are pre-rendered computation of some sorts. So they rendered and computed the frames beforehand and then just recorded it into a video. Where a game, we're rendering the frames continuously each second, each millisecond, in this case 60 times a second. This clock measures time in milliseconds. So we're going to check how many milliseconds needs to pass until the next frame. So that gives us a frame every 16.667 milliseconds. We get a new image for a 60 frames a second window. So every 60 frames is 1,000 milliseconds. So we divide that 60, we get 16.667 milliseconds per frame. So here we have 3 custom fonts of different sizes. We have a font for our button, we have a normal font, and then we have a larger font, which is almost double the size. So from the Pygame library, we have a submodule font, and we have a function system font. So firstly, it's going to be the name, like we can see here, name, and then we're going to pass the size, and then if we want 2 bools, so 2 flags for bold or italic. Now, we don't care about bold or italic, so we'll leave it empty, and we'll only care about the first two. We'll leave an empty string to let it know there's no name, and then we'll just give it a size, the size of that specific font. So the button will have the largest font. Now, it's important to note this font is in pixels. So if you have a very large screen with a high pixel density, like a 4K screen, it's going to look different than it looks on a full HD screen with a quarter of the pixels. It's going to look quarters as large on the full 4K screen. Then we'll create 5 constants. These 5 constants will store RGB values, so they'll have 3 values from 0 to 255, so the color value. Now these are tuples, so we might as well make it a const because we can't override it anyway. Now let's go to our game file within our main loop, within our while loop, and we'll add our frame rate and our blank screen. Now remember, from the config file we've just created, we have this clock we've created, frame rate, a special clock that doesn't work like a normal clock. It keeps track of when it's a time to draw the new frame or when it's a time to do something. So not necessarily a new frame, but it keeps track of when something should happen within intervals. So we have our clock and we're telling it to tick. So tick down at a certain rate. And what is this rate going to be? Also from our config file, we have that FPS. So we're telling our clock to tick at 60 frames a second, which is 16.6667 for every 16.6666 milliseconds a frame. So then after that, so firstly we get our time for our loop. So we want to put this as the first code within our game, within our main loop. We keep track of our clock, keep track of when is the time for the loop to tick, all within this. Then we want to draw a black surface to our screen. We're going to use that game window surface. So every time we want to show something to the screen, we're going to have to use this game window. It's the only surface that's displayed upon the screen. So if a surface is displayed on something else, it doesn't matter. It's not going on the screen. It has to be on the game window. So we're going to fold this surface with a color, so a tuple, a constant tuple. That's going to be 0, 0, 0. So it's going to be black. It's going to have RGB value of black. Now in Pygame, if we want to check for our key inputs and keys, we have to check for events. So we have to use a for loop to go through each event. So we don't want to check each event individually outside of a for loop. We want to use a for loop to do it. So we'll say for event in, so the Pygame library, submodule event, so for event within this. And then we'll use the function get to get it. So we'll get the individual event, which are these ones. So if we want to be able to quit, so not the escape key, but when we run in window mode, we have an exit button at the top right, like most applications have. So if we want to be able to use that, we'll create an event. So we'll say if event type, if it's equal to Pygame.quit, which is the exit button in Pygame.quit, we'll say playing is false. So playing is our control variable for our while loop. So the moment it's false, the game is over. Now we'll check for key inputs. So key down and key up. So key down is when you press the key and it's actually going down, like it's describing key down. So when you press the key and you hold it down, what happens? And then key up is what happens when you release the key. So we'll check if a event key, so if we're typing a specific key, what key are we typing? So what is it equal to? The escape key. So now I've set here, so you can press the escape key on your keyboard and the game will also quit because playing is false. So quit is the escape button and key escape is the escape key itself. And for now, we're just going to pass key up, but we'll have it there as a placeholder because we'll use it within the next lesson shortly. So we have this pygame.display update that this does exactly what it describes. It updates our display. Now, if we add this at the beginning of our game and we jump, what will happen is nothing will happen in that current frame. And it will actually be stationary and we'll need to have moved to the next frame before we see this jump. Whereas if we add it, so we have all the main game code, and we add it at the very bottom, we'll immediately, once it's added here, we'll update our display. So we'll be able to see the very same frame, this jump. So let's say we have a mechanic here, event key, and we check for jump, and now you press jump. So the jump has been pressed, and now you get to this display update. It's going to already start updating the display to show the jump. Whereas if you add it at the very top, you update the display first, then you execute the code. So now you jump, but there's no update display here. So you go to the next frame. So it takes an entire frame later for this jump to be visible because it's at the very top instead of the bottom after you've executed all your code logic. So when you should be jumping and display should be showing this frame, the current frame you're on, but what's happening is it's showing it in the next frame. So you're basically one frame always behind if you add it anywhere else than the bottom. This code is going to execute, and only once everything within that loop is executed do we want to update our display, not beforehand, or we'll get this delay. So we want it to be on the current frame, not the second frame. And then at the bottom of our while loop, outside of the while loop logic, so once the while loop has finished, so we're done playing, game's false, we have this return statement of this string, which is menu. So we want to return to our menu we'll create just in a second. Now let's import our operating system. We'll import our system and we'll import our garbage collector. So at the bottom below, when we're drawing our black screen, and we just post this code for our garbage collector. So we'll say GC enabled, garbage collector enabled. So just make sure if it's off that we force it on by default. And then we'll say collect equals true. So we'll collect long and short-lived objects from our trash. It will allow us to free memory immediately if there is available space in wasted memory. And we don't have to wait for the next automatic cycle. Because remember, in Python, we don't really have a lot of control over our own memory. Now let's add our menu controller so we can control the state of our menu. if we're on the menu, if we're exiting, or if we're on the sound. So we dictate the state of our game, what needs to go, what's running, what's not. Let's just make sure we properly quit. So we'll just add the system exit as well to make sure we exit the program correctly. So if we look at our menu file, so the module we'll create, we'll import the Pygame library, we'll import our operating system and our system, so we can do system-specific tasks like exit properly. We'll import our config file, because we're going to need some of those values. Then we'll create an empty list to store our images for our menu, because we're just going to loop 89 images. So you can see here 89. It says 88 here because we start from 0. It's giving us 89 images. Store our image within menu background. Using a for loop, we'll go through all of them. We'll use the Pygame library. We'll use a submodule image, and then the function we're going to load. Then we'll use this operating system that we've imported. We'll check the path of our directory. So we'll check our directory. We'll join the image. We'll use an f string, so a special f string, so we can use this variable. So we'll use the I, so for I in our list. So for each item within our menu background folder, it has to be a PNG as well. So each image has to be a PNG. And then we convert that specific image. So we save the alpha values. So using either convert or convert alpha is one of the most performance optimizing tricks you can do in Pygame. There's many tricks you can do, well, not even tricks, but there's many things you can do. But I would say converting your images to the correct pixel format is probably the best optimization you can do. So the reason we use convert is the images we are displaying and loading from wherever we got them don't always match our this internal game resolution perfectly. It might be too large, it might be too small, it might just not be right for many different reasons. And this causes, like when we move the images, blitzing mismatches. So this is very costly and we want to avoid it at all times. Now here we can look at the two types of converts. So on the right hand side, we have normal convert. And on the left side, we have convert alpha. So we can just think of these squares as pixels. Like our screen is made out of pixels, the monitor itself. And it also is red, green, and blue. So your pixel is an RGB screen. Now, if we just use normal convert, you can see the images according to their draw format. So this one is drawn first, then the green one is drawn, and then the blue one is drawn last. So the blue one overlaps all of them, and you do not see any color blending. So this is very optimized. It's if you don't need color blending of pixels or images, it's very performance reliant and much better than using convert alpha. Like for example, if later on we'll have laser sight, and we can just use normal convert or just use rectangles for that matter, instead of having to use the alpha value. Or if you have a lot of effects and you don't care about transparency, you'll use the normal convert. Now, when you're using convert alpha, you're saving what we call the opacity value. So that's how transparent your color is. So screen has RGB, so red, green, and blue, and from 0 to 255 for each one. So that gives you a possibility of 255 multiplied by 3, or multiplied by 255 multiplied by 255. But then we have a fourth one, which is also from 0 to 255, which is the transparency, the opacity. So the more transparent it is, the more see-through something becomes. And this is important because we're going to use convert alpha. This does, if we have our 3 pixels of different things, so let's say each one of these pixels are a different object, what will happen if they all have some kind of transparency value? We will be blending all the colors. So red, green, and blue together makes white. So if this is a different color, or each one of these are a different color, this white will change. It might be a little bit more orange, it might be pink, it might be whatever. But the important thing to note, it is slightly more costly because you are blending these pixels of different surfaces together to get a new color. Now, the reason you would do this above using the normal convert is, let's say you have particles like smoke, or you have an effect which is semi-transparent, so you still want to see the background, like flames and there's edge cases. You don't just want to make it a solid thing. You want to be able to have those transparency values to create a believable effect. You use the convert alpha. You can also use it without any performance delay if it's only one surface. For example, in our menu, we're only displaying one image at a time, and we're not displaying anything underneath it or above it, so there's nothing to blend. If we did add something underneath the surface, the opacity would be a bit more costly than currently we are using it. Then, after we've loaded our image and we've converted it using convert alpha, we take that same image, so again, menu background, and from the Pygame library, we call the transform submodule. There's a function within that file, scale, which is responsible for scaling images. What do we want to scale? We want to scale our menu background because this already contains the image. We've loaded the image here. So in Pygame, we use pygame.image to represent the image that we're going to place upon our rectangle. Then we pass from our config file, we have the screen width and screen height. So we have 1920 or 1080. So this is a full HD resolution. After we've scaled our image, so it's completely full screen, we basically stretch it to be full screen because the current images aren't the perfect ratio for a full HD 19 by 10 screen. Then we'll append. So each time we run our loop, we load an image, we scale that image, and then we append. So we add that image to our list. So we have an empty list, not anymore. Start within the for loop, we start adding images to this list, 89 of them. And what image are we going to add? This menu background we've been using. And within this file, we'll have 3 functions. We'll have a function to draw our buttons. So we have UI buttons. Tell it what text do we want to write, so a string. So what are we writing upon the button? The X and Y coordinates of the button. So where is the button on the screen? So these are pixel coordinates. So 0, 0 for X and Y starts at the top left corner. So if you add Y positive coordinates, we're going down. And if you add positive X coordinates, we're going across horizontally. So at the bottom will be the largest value for Y, and at the top right will be the largest value for X. Okay, and then we pass the width and height, these parameters, when we create our function, telling it what width it has to be, what height it has to be. And then we're going to have 2 types of colors. One when it's not active, so when we're not hovering above the button, and one when we're hovering over the button. Then we'll have a menu screen function, which will be the main function that will do most of the work. So we'll run a loop. So when we're in the menu, this one will be active, and we'll just be using these ones within it. And then we'll have a draw text that does exactly that. It draws text for our UI. This is not for our menu, but later on we'll use it for any UI effect we will need. Like we'll have an ego at above or whatever text we'll have. We'll use this draw text. You can use it in the menu. You can use it outside of the menu. It's a standalone function. Same is true for the button. It is important to note, even though it is technically, like I slightly misspoke there, even though it is technically less taxing if we only have one surface, because there's no blending of multiple surfaces, we're still using a different process. So we're still using that alpha value, even if it's not blending it. So it's still a little bit more performance heavy than normal convert. So later on, we can just use normal convert for our menu. I kind of just have a preference for convert alpha. But when there's no need, we can save the performance, even though it's minuscule. It might make a difference on someone else's computer. So here we have our for loop loading our images from our menu folder. Now if we go to our folder, we can see we have a menu folder. And here we have 89 images from 0 to 88. And all we'll do, we'll just loop through them. So within our draw button function, we have this mouse variable, and within inside it, we'll use the Pygame library. We'll have the submodule mouse, and we'll have a function within it that gets the position of the mouse. So it stores the current mouse position, so the mouse as it moves upon the screen, it has a pixel value. So remember that our screen is just made out of pixels, and our grid will be 1920 by 1080. That's the amount of pixels. So it can be within any one of those positions from 0 in width to 1920. So that range of X, or in Y, 0 to 1080. And it stores it within a MX and MY. So mouse X position and mouse Y position. Now a standard mouse has 3 buttons. We have the left click button, we have the middle button, and we have the right button. So left, middle, and right. So we store clicks, so we check if the mouse is clicked. We store it within this click variable. Again, the Pygame library. We have a submodule within it, same as here, mouse. But now we want a different function within that file, within that module. We don't want to get the position. We want to get if it's pressed. So both of these get something of value from our mouse. The one gets its X and Y position. The one gets its click state. As the info lets us know here, it's a tuple of booleans. So it cannot be changed. It's left, middle, and right. You can't make left, right, and right, left, and middle by something else. The positions are fixed because it's a tuple. And it's a tuple of integers, the left mouse, the middle mouse, and the right mouse click. So each mouse has a value, an integer value. The left click has 0. The middle mouse button, so your scroll wheel you press in, has 1. And the right mouse button, so right click, has value of 2. So if you want to check if we're clicking left, you check for 0, and the others are the same. Then we have to create a rectangle because we want to check if our mouse button, our mouse, is over something and if it's clicked. But how are we going to detect if it's over something and if it's clicked? So we get the mouse X and Y position and whether it's clicked or not. But we need to track whether this mouse is colliding with something. So it can be click. You don't just want to have a click and then anywhere on the screen and the button works. You want to check for collision. So what we'll do, this is our game buttons. So we'll have our buttons here. We can see we'll have a rectangle. Within inside the button. So when we hover over a button, we'll actually hover over this hidden rectangle. And we'll know, because we know what the rectangle's position is, it's fixed. It's a UI button. So we'll know if the MX or MY collides or are similar, then we know we're overlapping this rectangle. We know we're overlapping a button. And then when we check for click, left, middle, or right, then we can actually activate our buttons. Now let's create the color of our button. We'll create a button surface. We'll draw our rectangle of our button, and we'll have a game window that will blit. So we'll actually then draw the button itself. Now if we look, we'll create a color variable that will keep track of our color. So we have two colors, an active color and an inactive color. So we'll check if, now remember we have this mouse position, which are coordinates. So it's a X and Y coordinates. So we're checking if this X and Y coordinates is colliding. So is there a point? So colliding point means there's any point within the rectangle that it's colliding. And what rectangle? Not just the word rectangle, but an actual variable rectangle we've created above. So is this hidden rectangle colliding with our mouse position? Is our mouse over the button that will be at the bottom? If this is the case, we set it to active color, else it's inactive by default. So we are drawing a transparent button. So if we're not hovering over it, we want this transparent effect. Now, if we just draw a normal RGBA, so red, green, and blue, with the alpha value, so a 4 tuple, 255 multiplied by 4, itself by 4, so then if we display that, the alpha value will be ignored if we display it on a normal surface. It will basically throw away the alpha value. So what we have to do is we say, hey, Pygame, we want an alpha value. So this surface is a surface that allows us to use that alpha value. It will not throw away that last tuple value. So it will not throw away that last alpha value. If we omit this line, it's guaranteed that our colors will not be alpha. It will just be its normal color, whatever it is, the alpha value will be scrapped. So this is vital for getting the transparency effect that we want later on. Now we've created the button surface internally, but nothing is really shown to the user. So we have to draw it, which makes sense. If it's not drawn, it's there, but it's not there. So what are we going to draw? So from the Pygame library, we're using the sub module draw. There's a rect function within it. We're going to draw what? This button surface we just created. We're going to give it a color. We have this color variable dictating if it's active or not active. Where are we going to start drawing from? From coordinates 0, 0 of the button surface. So this means if the button surface is here, this corner, let's change colors. This corner is 0, 0 because in Pygame, X and Y starts from the top left corner 0, 0. The same with the game screen. So 0, 0 in our game window is at the top left. Now for each object, it's the same. The top left is 0, 0 here. So if we start from there, and Pygame draws horizontally and then down. So we're going to draw literally over the surface, which is what we want. We want to draw the button exactly where it is. So we give this 0, 0 coordinates to indicate we start from the top left and then we draw a button. So it's going to perfectly overlap. Then we're going to pass the width and the height. Notice it's the same width and height here. So it will be a fixed width and height that will pass when we create the buttons. And the rectangle will be the same. And the button surface will be the same. Same width and the same height. And it will start from the same coordinates. Then we draw a border radius. So we slightly curve out for a smoother button. If you want a more square, traditional looking button, you can ignore the border radius. If you are crazy and you want an extreme border radius, you can almost make it a circle the more aggressively you put this. Then after all of this is done, we want to blit our button. So what are we going to blit? Our button surface, and we're going to have an X and Y position here for it. So we have this draw ability here, but we want to, after we put it here, we want to copy it and paste it on the game window. Because remember, the game window is our game surface. So even if we draw it here, it's not going to show by drawing it. We have to draw it on the game window. It doesn't come on this game window surface. Remember from earlier, that's the monitor surface. It's not displayed. Now we're going to use Pygame font renderer to display text upon our buttons. Now remember earlier in our config file, we created these 3 types of fonts. So their size. So now we'll target our button font. So we'll store our text surface. So I'm going to create a surface to place our text upon. So we target our config module that we have imported, that we've created. So our config module contains these fonts that we've added. We target our button font. It's the biggest one, so it's perfect for our buttons. Then we're going to use Pygame renderer to actually render this text surface. So what we're actually passing is we're passing a font. So it's pygame.font.render here. Now, what do we want to render? At the top, we have our text string. So when we create our button, we're going to pass a string that's going to say something like load, exit, whatever the UI button is. Now here we have a bool that's going to ask true or false. And what is it checking for? It's checking for anti-aliasing. So do you want anti-aliasing upon our text or not? Now, what is anti-aliasing? When you see text, because the text is made out of pixels, so blocks, because that's what a monitor is, sometimes it looks a bit edgy. It doesn't look smooth. And that can cause kind of a blurry effect, especially upon small text. So the smaller the text, or the smaller your monitor's resolution, then more noticeable this effect. Now we are going to force 1080p in this game, so anti-aliasing might still be an issue. It shouldn't be at the size of 70 pixels. At 25, it will definitely be more of an issue. So we'll say anti-aliasing true. And then we have to pass a color to our text. So from our config file, so the file here, just below, remember we have those constant tuples that have our color value. So we'll pass the white color, say, hey, we want our text to be white. Then we have our rectangle. So with most things in Pygames, when we have images or text or anything, we eventually want to put it on some kind of a rectangle because Pygame is built to work with rectangles in the most optimal way. So doing something on a rectangle versus just actually doing blitzing with an image is always the better way to go. So we'll have this text surface, which is our image, our text. So whatever text we have, we place it upon this text rectangle. So we place our image upon the rectangle. And how are we going to do this? So we say this text image surface, we're going to get its rectangle. That means we take the image, or we take the surface, and we embed it within a rectangle surface. So they basically become one. So we can just move the rectangle, and whatever surface, if it's an image or it's a text, whatever, moves with it. It's much, much easier and more optimized in Pygame. So we're going to center this rectangle. So we want our text to be perfectly centered within this rectangle. So we're going to say X and Y, both plus their width and height. So we get the full size of the image, the full width of the X, and the full height. And then we're just going to divide it by 2. And then the height case, just because the text is slightly different, I'm going to move it down by 5 pixels. So it is technically perfectly centered without the +5, but I moved it just optically, it looks more centered by adding a 5 extra pixels in the downwards vertical position. And then after we've done this, we want to blit this text upon our game window. So we have our text surface and we have our text rectangle, and we're going to blit that upon the game. And this will place them perfectly where we want them. So here we can checking for a rectangle. So that, remember, this is the rectangle. We're checking if the mouse button is over for collision. So we say if our mouse coordinates at any point, so a colliding point, does it have any point it's colliding with? And is click 0. So my 0 is our left click, 1 is our middle click, and 2 is our right mouse click. And we say if it's 1, so 1 is true, 0 is false. So if it's clicked, so this is a bool, if it is true that it's clicked, we return true. So we check the state. So currently it's set up to be a state-based check, which meaning if you click and hold it in, it's possible to get multiple true returns. At the moment, it doesn't really matter. Later on, we might make it so if you click it, it returns true, and it might be a condition that forces you to check if you release the mouse. So it's event-based, more accurate. But for now, it's not going to matter. No real issues will be noticed. And if this is not the case, at the bottom of our function will return false. So we do all the code logic. Then we check if it's clicked. If it's not clicked, then we will just return false. So the state is false. Our button is not clicked. Else, if it is colliding over and the left mouse, so if you want to make it the right mouse, you'll put 2 here, is true, 1 for clicking, and we'll return the state is true. Now let's create our menu screen function in which our menu will live. So we'll have a while loop, which will actively keep our menu active and running. Similar to in our main file, we'll have a loop. Here we'll have a different loop. So within our menu screen, we'll have a local boolean. So in menu, it's going to check, are we currently in the menu or not? It's going to keep the state of the menu. Are we in it or not? Then we'll have this global variable is paused. So later we'll use this. We'll play music in our menu and we'll want to check if it's paused or not. So we'll have this global variable so we can keep track of it, if the music we're playing is paused or not. Then we'll have an index and we'll keep track of our current index using this variable. Now you can either spell the index out fully, or sometimes if I'm lazy, I'll just say IDX for index. So remember, our menu is just the images that we are switching between. So we're looping images, one, and then we're showing the next one in the list, next one, and then we're looping the list. So we want to keep track of when was the last time we switched. So I'll have a clock, and this clock is not like our special clock that keeps track of how many frames we have to show. This is a normal clock. So this clock just ticks in milliseconds down. So 1 second, 1,000 milliseconds. So it just continuously goes like a clock, tick, 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 tick. So we'll need it to keep track of when was the last time we switched. And then we'll have a variable that will determine what's the interval that needs to be switched. So 1 second, 1,000 milliseconds. So we are swapping a picture every 1 second is a new frame. Now, if you have a picture that's an animation or a fire, like one image, but you're in terms of one scene rather, but you're looping images that are all slightly different, like slight movement, like flames or fire or smoke or water or just breath of a character idling, you want to make it maybe like 100 milliseconds, so 10 frames, or maybe even 10 milliseconds. That might be a little bit too much. You might want to make it like 25 or 20. So every 20 milliseconds, you move to the next frame. This will give you a very fast looping animation. It will be more like a video. So currently, it's not set up like a video. It's set up just to loop the images. If, like I said, if you want a single scene of a fire or whatever the background is, like some games have, smoke, hover, whatever, you might want to increase the switch interval drastically. Our menu is going to repeat while we're in it. We're going to stay within the menu state. So we'll use a while loop to continuously keep us in the menu. So in our main while loop, so we check while we're in the menu. So we have that state, that true or false, that bool. So we need to keep track of time so we know when it's the next time to update the image or frames. So say now we store time. So within the Pygame library, there's a submodule time. Within that file, within that module, there's a function we need get ticks. Just as a clock, it keeps moving, keeps track of time continuously. So we say if the current time on the clock, so if now, whatever time it is, and we deduct the last switch time, so the clock runs, then we switched, and we go through this, then we set the last switch time to the current time, and then we run again, and we have the switch interval. So we're keeping track of the current time minus the last switch time is larger or equal to the switch interval. And the switch interval in our case is 1 second. So we're continuously checking if 1 second has passed since the current last time and now has 1 second passed. So now must be at least 1,000 milliseconds larger than last switch time. So when we deduct this time, you can see a second has passed and it will be larger than our switch interval. So we continuously check if 1 second has passed. And then when we go to our loop, we want to update our frame. So our index, we say our current index, we increment it by 1. So we plus 1. So we go to the next frame. If it was 0, now we go to frame 1. If it was frame 1, now we go to frame 2. Now we check this against the length of our images. So we have this menu list, which is just a list with all 89 images. So 0, 1, 2, 3, 4, 89. So 0, 1, 2 until 88 in this case. And then we use the modulo operator to effectively prevent us from going over our list and going out of bounds. So we basically wrap our list around. So once we are at the last item, instead of traditionally when we go increment our list, it's going to look for item 89, so the 90th item, but there is none, so we're going to get an error. By using the modulo operator, this is just a very nice way of wrapping it around. And we start from 0 again. So we increment our list, we go through it until we're at the last item, and then using the modulo operator, we just wrap around our list, preventing us from going over and getting like an out of bounds error, which is obviously something you don't want. Now, after this is done, we set the current time. So this is the current time, and we store it within the last switch time. So the last switch time is now because we just switched. So we set the switch time to the current time. So when we run again, we can check if 1 second has passed here from the current time and our last switch time. So we can enter our if statement again. So in Pygame, the draw order matters. So because now we want to use our buttons, but if we draw the buttons now, and then later we draw our menu images, the buttons will be invisible because they're going to be drawn over. So remember, the draw order always matters. And it's not just for Pygame, it's true for most games, if not all. It's true for anything with computer software in general, due to how the screen has to represent things. Now, let's check. So what we do is we call our config file. Remember that module with all our specifications and things like that. We have this game window surface. We're going to split our images. So we're going to draw our images on this surface. What images are we going to draw? We have this list, this menu images over here. And within that list, we have an index. So the current image. So we're drawing the current image within our list that's loaded. And we're going to draw it from 0, 0. Remember, 0 and 0 for X and Y is at the top left corner. So we start from here, and we always draw horizontally and vertically down. So we're drawing from the top left corner all the way to the top right corner down. Now, after we've drawn our menu, now we can draw our buttons because we have already drawn the first image. Because if we do it otherwise, remember, like mentioned, it's going to be wrong and we're not going to see it. So we're going to have 3 buttons, a play button, one for sound, and one for accent at the moment. Later, we might change sound to something else, or we might even add one or whatever. So we'll call that function we just created at the top, the draw button function. Remember, we have to pass text, so what it's going to be a string. What do we want to write on our button? What's the text we want to write? Play, sound, and exit. Now we want the coordinates for our button. So it's going to be for the X and the Y, 800 pixels the play button. It's going to be 800 pixels in the X and 950 pixels in the Y. So you'll notice all the Y values are the same because we want to start them from the same horizontal position. But it's the X that differs because this is the X. So we want to draw a button here, and then we want to draw a button here, and for example, here or something like that. So the Y stays the same because changing the Y changes it up or down, but the X, the horizontal position, changes. So they don't overlap each other. And then we're going to have the width and height, which will be the same for all buttons, unless you want the buttons to look like different sizes. Then we're going to have our 2 colors. inactive and active. So we'll notice there's 4 tuples values. So we have 0, 80, 0. So we have red, green, and blue. And the last one will be our opacity. How transparent is the button? 0 is completely transparent. 255 is non-transparent. It's the same as here. So when we hover over our image, you'll see the alpha value just goes to its maximum. So the button doesn't become transparent anymore. It's fully visible. You can't see behind it. So we'll set colors. So red, green. Play will have a small value of 80 green, and it will become much more green when we hover over it, as well as the transparency will fall away. And we'll have green and blue, which makes kind of like a cyan type color, a light blue, and we'll exaggerate the blue effect. So going in a higher value increases the color and its brightness. So we'll make it a more bright blue, and we'll remove the transparency. We'll have a red color, more red, slightly tinted red. Also remove the transparency. Now below, we'll check the state of our menu and our buttons and what logic should be performed once these buttons are pressed. So we'll have logic for play, we'll have logic for sound, and logic for exit to determine what happens each one of these. So let's look at our options when we are in our menu. If play is pressed, so if the play button is placed, we return a string value of play. So once the play button is pressed, we return this value, and within the main game, we know it's time to go to the main loop. If we press the sound, we're going to check our mixer, so pygame.mixer, and then we're going to check the music of our mixer if it's busy. So are we currently playing a song? Get busy is checking if it's busy. Music is our music channel, and our mixer in Pygame allows us to play sound. Then we'll pause our mixer, so using the Pygame library, the mixer submodule, target music within that file, and we'll tell it to pause. We also have our global is paused that checks if the sound is paused. So we'll set it to true, so we know globally the music has stopped. Else, so if there's not a current song or the mixer isn't busy, we unpause our mixer and we say is pause is false. Now, if the exit button is pressed, if exit pressed, so sound presses the sound button, play presses the play button, exit pressed is the exit button. We quit Pygame and we tell our system to exit the application properly. Now we're going to use a for loop to go through our events. What events do we want to check? We want to check the quit. So we have an exit button, and we want to check keys, key down specifically, and the escape button. So if we quit using an exit button, we quit the game and we quit the program. If we press the button, we also do the same. We also, as an extra flag, set the playing variable to false. Currently, it's undefined, this variable. It doesn't know what it is. If we put it in config and we target it that way, it should target the same variable. And then we want to press the enter button that allows us to press enter when we're in our menu. So we don't just have to click to start the game. So if we are playing the game when we lose, if we don't want to switch then and go use the mouse now to click, we can just press the enter button. But this will only be allowed after 4 seconds. And the reason for this is when we load our game, there's going to be a slight delay. And we don't want to be able to immediately move to play using the enter button, because some of the things might not load properly and the game will load too soon. And later on, I'll show an example of why this is important. But for now, all we know is once the game starts, we're tracking time. Remember, we have that now variable that tracks the current time. And we compare if it's larger than 4 seconds, so more than 4 seconds have passed, and then we can press play. Now we need to update our screen and our frame rate. Then at the bottom of our game loop, we want to, just like in the main game, we want to update our display last after all computation is done. You can add the frame rate afterwards or before. It wouldn't matter too much because it's not computation. We're not doing something to an image or do something. So it wouldn't affect the display itself and what we're seeing. So we update our display last so we can see whatever logic we've done just above, like switch to the next image or click the button or whatever. And then our main game is going to run at half. So the game runs at 60, the menu runs at 30 frames a second. And the reason for this is it's a static images, mainly we're just flipping between, as well as the images are quite large in terms of data size. So one thing Pygame is not too effective at is showing multiple images. Luckily, we're blitzing them very slowly and changing them very slowly. But we can get away with 30 to save some CPU performance instead of needlessly making it 60, and the user will not notice a difference because we're only showing 1 frame a second. So we're updating each picture 30 times before it goes to the next one. Now we'll have this draw text function that we're not going to use in the main game loop, but we're going to use it anytime we want to draw a UI element other than the buttons. So when we want to draw text specifically. So we'll have the text that we want to describe, so the string. We'll have the font size, we'll have the text color, and we'll have the text X and Y coordinates. So it's position on the screen, which pixels should be on. Then we'll have this image, which will just be a surface we're going to render our text on. So we're going to say font. So we're going to have a specific type of font. And we remember we have those 3 fonts within our config file. So when we're calling this function, we're going to pass one of those fonts here. And we're going to use the Pygame renderer that will render this text. What are we going to render? The string text, whatever we're going to describe when we're going to pass. So we're going to pass a string when we call this function, describing the text that we want to draw. True for anti-aliasing, so smoother edges on our text, and then the text color. And then we're going to blend it to our game window, so our monitor screen. That surface everything gets drawn on. What are we going to draw? This image of our text. I'm going to give it X and Y coordinates. So we can use this anytime we want to draw text on our screen. Now let's go back to our main file within our main game loop. Now we can actually import our menu. So we'll go and import from menu. So from menu, we'll import our menu screen. So now when we go to menu, the menu screen is triggered. When we go to play, the start game is triggered. And let's see if it works. There we go. We can see the menu loops. The buttons work when we hover over them. I'll click at the end. Just want to see if it wraps around correctly. It should. I believe we've used the modular operator correctly. So the picture's just like the game. It's meant to be extremely outlandish and not to be taken seriously. It is a giant joke, as mentioned many times. None of this is a direct take on reality, but except a parody. So you can see all of this plays into our main protagonist's ego, as well as many of the things said in the game by either the politicians or the enemies. This is meant to take their own words, turn it up a notch, and just expose the ludicrousness behind it. A great example is of Marjorie Taylor Greene, who continuously mentions space lasers, Jewish space lasers. So we added Jewish space lasers to the game. Not that there is necessarily any Jewish space lasers. I have not seen any, but it's just hilarious to put it in there. Now we can see when we press the play button, we go to the game window. At the moment, it's a blank surface. And when we press exit, we go back. So the menu works perfectly. Now let's go to our config file and let's add our mixer. So from our Pygame library, we have a mixer submodule and we're going to initialize it. So we set up our mixer. So now we can use sounds. So we want to play some intro music. Now we have 16 available channels that we can set. So let's set them all. I believe it's 8 standard, but we're going to set it to 16, the maximum amount of channels we can have. Now at the bottom below in our config file, let's just create variables for each one of our channels. So we can just call it using a variable. So this is how we can assign a channel. Just using the Pygame library, the mixer module, we have this channel, and then we assign a specific channel to each one. Starting from 0 to 15, we have 16 channels. So we assign each channel to their own variable. Now let's go back to our main file. And for now, we're just going to create a basic playing music function. Later on, if it gets more complex, we might give it its own file, so its own module. We'll do some more complex things, and then we'll just import it. But for now, we'll just put it within the main file. It's not too long. So it's going to be playing music. And what are we going to play? We're going to play a specific song path. So we notice we have song paths that are basically just a path for our music for each individual track. So let's do exception handling. So we'll try to load our music. So we'll use the Pygame. So the Pygame library, the mixer submodule, we'll use music. From that music, we'll load it. So we'll load a song path. Then we'll set the volume for our mixer to 60%. So a full 1 is 100%, 0.0 or just 0 is 0%. And then anything, so it goes up in increments from 10%. So 0.1, 10%, 0.2, 20%. Then we'll play that music. So that current music in the mixer, we'll play it. That's how you play the song without looping it. If you add -1, you will loop it, but it's only going to be looping one song. Then we print that we're playing music, so we know we're playing successfully for like debugging later on. And we say the song path, so we know. So that's why we use the F string, so we can add this condition of song path. So what song path is it? If it's song path 3, we're going to show the name, so we're going to show this name. Or if it's song path 1, we'll show this song's name. And if this isn't the case, so we have an exception, use this exception. So except for exception as E will refer to the individual exception, so it will be the song that it could not load. So you can think of E as the individual item of the song. Song 1, 2, 3, 4, 5, etc. And then we'll just print, also using an F string, so we can add this additional step that lets us not just print something like a text of a string value, but we can add this variable and whatever it contains, which will be this path. So we're printing error loading music, and then this E just be the path. So we're going to print this. We set the current song to song 1 when we enter the game. So when we start the game, we set the current song to song 1. So we start from the first track, and we say is pause is false. So because we're going to start playing a song. And then we have this play music. So we call this function, and we call song path 1. So that's the song we're going to play. So later on, we'll add this song path somewhere else. It's no need to have it in the main file. Same with the music function when it gets more complex. But for now, in simplicity, I'm going to put it within the main file. Then within our start game function, when we set up a new game, we'll add that global variable current song. So we keep track of the current song being played. Now within our while loop, so our main loop of our game, let's just add a check to see if the song is finished. So we're playing song 1. Then when the song is finished, we want to change the song path to song 2 and play the new song. Same for song 2 to song 3. Let's look at this. So we're going to say if not paused. So we have the ability to pause our music. So if it's not paused, because we don't want to trigger the song to change when we're pausing the music, because that's the method we use to change the song. So then we check the mixer is not busy. So there's no sound. That's why we first check if it's not paused, because if it's paused, there's no sound. But we don't want to change the song when there's no sound. We want to pause it when playing music and there's no sound, which means the song is over. So it's a small difference, but it's vital to realize the difference between the two. Then, so we know the song is finished because our game isn't paused and we aren't playing music, which means it can only mean because we're continuously playing songs, the song is done. So then we check, because we know if the current song is 1, so we check if the current song is 1, and we change it to song 2. Then we play that song. Then we check if it's song 2. So now we know we're currently playing song 2, so we set song 3, so the current song to song 3. So we play a current song, like song 1. While we're doing that, we set the current song to the next song, so that when it's done, we just check. So we know the sound has stopped playing. Then we check for the song path, because we played, so we're in song path 1, then we change the song path to 2, but it's still playing the first song until it's not busy anymore. And then it checks for the new song path to be played. Now it's not 1 anymore, it's 2. So now we move to the current song path 2. So this elif statement. Whether we do the same, we change our current song path to the next one, but we're still only playing song path 2. It's only in the second song now. But again, when we're not busy, so the song is over, then we check again what song path we are in. And it's no longer song path 2, it's now song path 3. So in this case, we don't have a fourth song, so we just turn this to an else statement. We turn this current song back to song path 1, so we are at the last song of the list. So 1, 2, 3. Go through them, and once we're at the third one, we want to turn it again back to the first song. So our music continuously plays, and then we'll call that song path. Now, at the moment, this is slightly incorrect. We're skipping song 3, so we have to make this song path 3, not song path 1 again. So song path 3, not 1 here. We'll fix that slightly a bit later, but you can fix it at this exact moment. And then let's quickly run it and see if it runs perfectly. We get an error for channel attribute error. So let's go to our config file. Where we declare the number of channels, we seem to have an issue. We forgot that we have to target that mixer submodule. Otherwise, we're targeting something that, according to our program, doesn't exist. Now we can hear the music. Now here we can notice one major setback to checking the sound as we are currently. It checks per frame, and we're running 60 frames a second. So the sound is both pausing and unpausing while we're having the click down, because the computer is running so much faster than us. So let's go to our menu. So let's create a small delay. So once we've clicked, we'll add a 1 second delay. So we'll have that sound cooldown and a sound delay. So with this, we can keep track of once pressed, we have this 1 second delay. After the 1 second, we can press again. We'll add this sound cooldown and this sound reset. So we'll reset the cooldown. So we press it, we give sound delay, we reset the cooldown. Now this allows us to press it again. So if sound is pressed and the cooldown is 0, we'll reset that current cooldown to the current time. So for the new cooldown to take place. If we run it, let's check if the cooldown works properly. Yes. We click it, double click it, hold it in. It doesn't trigger multiple times. And when we enter the game, it unpauses. Okay, so let's change that song path in the main file to song path 3. Needs to be the correct song path. And we'll just go to our menu. Where we are converting our image. Instead of using convert alpha, we'll turn it to normal convert. because it doesn't need to have the alpha. And that's all. That's small tweaks for optimization and to fix a bug we had, a logic error. If you manage to follow this video without having extreme difficulties, you will be alright for the rest of the lessons, and it should not be too difficult for you. So with this game, we'll add many more crazy and funky features, trying to fit to the theme. Maybe we'll add the force hammer, currently working on it. Maybe we'll add some kind of nuke button for you to use, like a special ability. Thank you for watching, and until next time, have a good one. If you have any comments or thoughts, things you would like to see in the game, just leave it in the comment section below.